I'm Anil Kumar, and in this video we will see how composition of functions help us to solve many application questions. Now in this particular application what I'm doing is I'm taking example of a cone. So let us say we have a cone here. So that is the cone which we are considering, and we are interested in finding volume of the cone, right? So let me just draw a cone like this, and that is kind of center, and this is at the right angles. So in any cone what we have, basically we know two dimensions of every cone most of the time. One is the radius, right, and the other one is the height. Now depending on radius and height we have the formula for volume. So we say volume V equals to 1 over 3 pi r square h, where r is the radius and height is h. So this particular relation, volume of a cone as 1 by 3 pi r square h, is a relation in two variables. But in case I want to solve this equation, then most of the time I either need a relation between the volume and radius, or we are looking for a relation between volume and height. So we are either related, we have to relate volume with height or with radius. Since let us say I say that this cone is being filled by something, and we want to find out the rate at which it is being filled at a particular radius or at a particular height. Those are the kind of problems which are very tricky and difficult to solve. So how to solve such questions, right? So let us assume that we are pouring some sand here, right? So it just piles on in the form of a cone, as you know it will, and we need to just find the volume of this at any instance of time, right? So we could also relate with time if we know a rate at which the sand is falling, right? So let us say we know what is the rate at which the sand is falling. So we know the volume which is being added on, right? So with time we know volume which is being added on, and we need to find the volume at which it is changing the height, for example. How are you going to solve such a question? And that's a big issue, right? So we are going to solve such questions in calculus or in advanced functions, but for the time being, let us first understand basic thing, and that is how to write an equation in single variable. That is first and foremost. So if I relate this volume in terms of radius or in terms of height, and if I know volume in terms of time, I can relate all of them, and this is where composition of functions come into picture. So I think with this particular example you have a fairly good idea how important this topic of composition of functions can be, right? So that is what we are getting into. Now in such cases, what do you normally do? So when you are given such a situation, we take help of similar triangles, right? And we know the ratio of radius to height, and this ratio helps us to solve the problem, right? So the thing or the key issue which helps us is similar triangle in such cases, and it is the ratio of height and radius that helps. So most of the time in such cases you know this ratio or you can figure it out, right? So let us say for simplicity that this ratio is 3:2. Let us say, right? So that is the ratio given to us. So this cone is being formed where the change in height with change in radius is in the ratio of 3:2. Now this helps us to relate height with radius. So we can say, well, that means height is equals to 3 over 2r, or we can say r is equals to height times 2 over 3, right? So if we know that kind of a relation, in that case we can very easily write our function which is volume in terms of either radius or in height, correct? So we could write this equation as, we can say volume in terms of height should be equal to, we'll replace r with the relation in height. So we'll say it is equals to 1 by 3 pi, and instead of r I will write 2 by 3h whole square. Do you see that? Perfect. So that is the relation, and it'll, when you open this out, you get 1 over 3 pi times 4 over 9 h square, or you can write this as 4 pi over 27 h square. So you have a relation which relates volume with height. Now you can do the same calculations for volume with respect to radius. So you can say volume as a function of radius should be the same volume expression, 1 over 3 pi. You need r, so keep r as such. Instead of height, write down 3 over 2r. Perfect. Now you can simplify this. So 3 and 3 cancels, so you get pi over 2 r cube, correct? So 3 and 3 cancels, pi over 2 r cube is the volume in terms of radius. So now we have two expressions. Do you see that? How simple expressions are. V over r is equals to pi over 2 r cube, and we have volume as a function of height is equals to 4 pi over 27 h square, right? So these are two expressions in volume which we know, correct? So that is the expression in volume which we know. Now suppose I tell you that the rate at which the volume is increasing or the volume is getting added is known to us, that is, we are adding change in volume with time is, let us say, 10 liters per second. It is 10 liters per second, right? That means the relation is volume with time is equals to 10t. Do you see that? So the volume is increasing with time at this rate. That means we are adding this sand over this pile, which pile takes the shape of a cone, and the volume being added is 10t. Now the question for you is, relate this volume with time, right? You could use any of your relations, and now for you the question is that you have to relate your volume with time. How are you going to do it? So that is what you need to explore, right? So composition of function helps us to write any relation in terms of different variables, and we can actually go on and on like this and add as many variables as we want to and solve a multivariable question with the help of such combination of functions, right? So I hope you appreciate the topic. We'll further look into this in the next video. Thank you and all the best.